Today we're going to talk about solving quadratic inequalities. And there's really a couple of basic types of this: inequalities that factor and inequalities that don't factor. And today we're going to talk about just the ones that factor. So real solutions only is what we're going to be talking about today. So we have some sort of a quadratic inequality. And the first thing you want to do is you want to figure out what we're going to call the critical numbers. So you want to figure out what are the critical factors, the critical numbers. So you're going to factor it, and your critical numbers then become -3 and 2. So it's as if saying, if this equaled 0, what would my two solutions be? And you're going to put those on a number line. And then all you're trying to do is figure out what solutions will make this equation greater than 0, because this is a greater than 0 symbol. So you're going to pick some number on the far left of your number line past -3. So -4, -5, -100, -1,000,000. It doesn't really matter. And just mentally put that number into your inequality and ask yourself, would it give you back a positive or a negative number? So let's just pick -100, for instance. So if I pick -100 and squared it, I would get a positive number, and that number would be much larger than any negative number that these two would create. So I know any solution from -3 on down would end up giving me a positive solution. By the same token, if I added in any numbers on this side, 2, 4, 8, positive 100, it would also give me a positive solution. And if I picked a number in between, for instance, 0, if I plugged in 0, I'd get 0 plus 0 minus 6, so it would give me a negative answer. So here you have your number line, and it shows you what solutions would give you positive answers and what solutions would give you negative answers. You are looking for where your solution is greater than 0, so you are looking for solutions that would be in this area and in this area. And again, I did open circles instead of closed circles because this is greater than, not greater than, or equal to. So therefore, your solution set would x has to be less than -3, or x has to be greater than positive 2. Let's try another one. So here's your inequality. Again, I'm going to factor it. I'd look to see if I could divide through by a common denominator, but I can't. So I'm going to factor it. And again, once again, if your factoring skills are not strong, please see me, and there's some really simple ways that you can factor, or go back and look at the factoring videos that I had put up earlier. I'm going to put my critical numbers on a number line, and this one now is less than or equal to, so you can see I kind of colored them in with a colored dot because it's equal to is now part of my solution. I'm going to test each interval mentally. So if I pick a number greater than 3, like 100, for instance, 100 squared would give me such a big number that it would outweigh the -5x minus 3, so it would get a positive solution there. If I plugged in 0, I'd get a negative solution. And if I plugged in a really, really small negative number, -100, -1,000, when I square it, it would become positive, so any solution in that area would become positive. You're going to notice that these very often switch positive, negative, positive, or it will be negative, positive, negative. I'm looking for where is it less than or equal to 0. So now I'm looking for numbers that are negative, because those are the types of numbers that would be less than 0. So now my solution is going to be in this area right here. So this is an in-between conjunction. So if you remember, when you write an in-between conjunction, you're going to write the smaller number on the left, the larger number on the right, x will be in the middle, and your two signs in between will always be less than signs. Don't write this backwards. Don't write it as 3 is greater than or equal to x is greater than or equal to -1/2. That, I suppose, is technically correct, but it's not really the correct mathematical way to write an inequality. So we won't write it like that. All right, here's another one. In this case, I usually don't like my leading coefficient to be negative. It's more difficult to factor it. So I can just go ahead and divide through by a negative number. But remember, when you divide through by a negative number, you're going to flip your inequality sign. So now this is the equation here that I'm going to be working off of. I can factor it. My critical numbers then are -2 and +3 over 2. Again, I have open circles because it's greater than, it's not greater than or equal to. I'm going to test each interval. So again, I'm working off of this equation, don't forget. So if I plug in 100, it's going to be positive. If I plug in 0, it'll be negative. And if I plug in negative 100, for instance, it would be positive. I'm looking for where is it greater than 0, so I'm looking for where is it positive, so I'm looking my answers that are in this area and my answers that are in this area. So therefore it is an OR conjunction. So it'll be x is less than -2 or x is greater than 3/2. Here's another one. So in this case, I want to factor it, so I'm going to set it equal to 0 by subtracting the 27x. I can factor out a 3x. And now if I set them both equal to 0, 3x equals 0 or x minus 9 equals 0, I get my two critical numbers, 0 and 9. I'm going to test each interval. So if I picked a positive number, 10, 11, 100, a million, I would get a positive answer. If I pick something in here, for instance, the number 1 would be easy to test, right? So this would be 3 minus 27, so I would get a negative answer. And if I plugged in a big negative number, I would get, or small negative number, depending on how you look at it, I would get a positive answer. I'm looking for where is it less than 0, so I'm looking where are the numbers negative. So the numbers are negative between 0 and 9. All right, here's another example. We're going to factor out the 3. When we factor out the 3, we're going to get x squared minus 16. X squared minus 16 would be the difference of two squares, so x plus 4, x minus 4. So I'm going to have two critical numbers, 4 and -4. And I could have divided through by 0 here. It doesn't really matter. I mean, divided through by 3, I'm sorry. It doesn't really matter. Again, if I test my intervals, greater than 4 would give me a positive. If I plugged in 0, it would give me a negative number. And if I plugged in negative 100, it would give me a positive answer. I'm looking for where is this greater than or equal to 0. So this would be an OR conjunction because I'm looking for where the numbers are positive. So they would be positive when x is less than or equal to -4 or greater than or equal to 4. Let's take a look at this one. So this one's a little unique. This one factors to x plus 3 squared greater than or equal to 0. So now I have one critical factor. Again, I kind of have it twice, but that doesn't really matter for my number line here. I'm going to do the same thing. I'm going to pick numbers that are greater than positive 3 and test them. Greater than -3 and test them. So let's say I plugged in 100. That would give me a positive answer. And if I plugged in a negative number, it would also give me a positive answer. So no matter where I am on this number line, I'm going to get positive numbers. So therefore, if I'm looking for where is it greater than or equal to 0, my answer would have to be all real numbers. Any number I plugged in would make this true. Let's take a look at this one here, though. If I had x plus 3 squared is greater than 0, now my two critical numbers are -3. I'm going to give it an open circle now instead of the closed circle. So now all my positive, if I put a big number in here, 100, it would still make this positive. If I put a negative number, it would still make it positive, but -3 itself would not make it true. So now the only solution is all real numbers except x cannot equal -3. And what if I flip the sign? Now it would be no solution because I'm looking for where is the solution less than 0. And on either side of my critical number, -3, I get a positive answer. So there's no place that it would make it have a real answer. And if I did less than or equal to, now my only solution would be at x equals -3, because that is the only place that would make that a true statement. So when you only have one critical factor like this, you really have to pay attention to the sign to see what your solution would be. We'll save non-factorable for another day.